Welcome to Easy Math TV. In the previous video, we set up a Pascal's triangle, and I promised you that in the video right after it, we would use that, and we are going to do that today. We're going to set up our a probability distribution table, okay, PDT, probability distribution table, for a random process that has two outcomes. So it's called a binomial distribution. And these are probabilities that are not given to you, so we actually have to calculate them. And that's why it's going to take a little bit of time to get this set up. The columns that are covered over right now, we're going to make use of those in a later video. But for today, we're going to just set up the probabilities for a binomial random variable. So let me read to you our goal. Our goal is to create the probability distribution table for a random process that has two outcomes. So think in terms of like random process, you're going to repeat that process, but each time you do it, there are two outcomes. So each time you make the attempt, you either succeed or you fail. And the random variable x, capital X, measures the number of successes, little x, out of n trials. So we want to have n be flexible. And that's why for this particular table, n is going to be allowed to be anything from one trial all the way up to 15, because that's what we had our Pascal's triangle based on. So for the number of trials going anywhere from 1 to 15, we want this table to be effective, usable again and again and again. And this is part of what statistics is all about, is you want to make things reproducible. So can you reproduce the same kind of scenario, but just change a few of the parameters in it? So just let me give you a couple of examples of how we might be able to use this information that we're getting here. We could answer any of these three types of questions that you see here. So here's some applications of what we're doing. One, what is the probability of getting anywhere between 4 and 6, so 4, 5, or 6 free throw shots out of 11 attempts when we know that a player's free throw success rate is 0.42 or 42%? So we have a player, their success rate is 42%. So 42% of the time they make their shot. So what is the probability of them getting somewhere between 4 and 6 out of 11? That we can calculate that using this table. A second type of question you might see, what is the probability of getting less than 3 heads if a coin is flipped 7 times? And then the third type of question, what is the probability of incorrectly testing positive for a disease? In this case, it's breast cancer, if tested for the disease 3 times, and the false positive rate is 0.11 or 11%. So every time a person receives a screening mammogram for breast cancer, there is an 11% chance that they could test positive, but they don't have it, but they don't have breast cancer. So we want to know what is the probability of that happening if they get tested 3 times. Okay, if they get tested 3 times. So and they just test positive 1 out of those 3 times. So we can answer any of those questions using this distribution called a binomial distribution, because every one of these things involves an outcome that has two things could happen. You either test positive or you test negative. You flip a coin, you either get heads or tails. You try for a free throw shot, you either make it or you don't make it, right? Those are all things that have two outcomes, but multiple attempts. So that's where the binomial distribution comes in. All right. All right. So we need a starting point. So at the top row, these are numbers that we're going to provide for creating the rest of our table. So let's do row 1 first, and then we'll talk about our headings, okay? In row 1, we first need to specify what n is. So I decided to just make it equal to 11. And I've also colored in that block because for future reference, if I ever want to use this again, I know that I have to change or update that number. And then we need the p-value, or the probability, or the probability of success. So the probability of success for, and this is the free throw situation, is 0.42. And then we need the probability of failure. And the probability of failure is 1 minus that value. So in E1, we're going to type equals 1 minus D1. Okay, equals 1 minus D1. So that is not a number we're going to actually have to type in every time. It's going to get calculated for us, which is why I have it highlighted in blue instead of the salmon color that you see here. And we're going to label that 1 minus P. And in some books, you'll see the letter Q being used. So you have the probability P of success and the probability Q of failure. All right, that's in E1. Okay, so that's row 1. That's just going to set up the numbers that we need in order to fill in the rest of our table. Okay, so column A, as usual, that's going to be our X's. I mean, this is pretty standard operating procedure. If you've seen my previous videos before, you know that this is going to happen. So our random variable X could take on values anywhere from 0 up to n. So we have to allow for all the way down to 15 there. But for this particular example, we're only going to go so far as 11. But I'm going to leave the 12, 13, 14, and 15 available to us for future problems, okay? So that means that our totals row is going to be down here in row 19, okay? Totals row. Okay. So we're going to need these, we're going to need columns A through F, and the headings are X, N minus X, frequency, and then we're going to take our P value and raise it to the X power. And then we're going to take our Q value, which is 1 minus P, and raise that to the N minus X power. And we're going to use, the reason why we've included all three of those things, frequency, P to the X, and Q to the N minus X, is we need to multiply those three things then to calculate our probability for each outcome, okay? So in the previous lesson that we were just setting up a probability distribution, we didn't need all this stuff in the middle here because we were given what capital P of X's were and the X's, right? So we were given all that information, but this time we aren't. So we have to calculate all of those. All right. So let's look at our N minus X column. N minus X is here. So in column B, so the first thing we're going to do is type in row 3 now, because I had to skip rows 1 and 2. In row 3, B3, type equals, and then it's $1 because that's where my N is, minus X, which is in A3. So again, it's equals $1 or Bravo $1 minus A3, alpha 3. Okay. And it should, right now, it should show up as 11 because N was 11, and 11 minus 0 is 11. Fill that all the way down to until you get a 0, until you have a 0 showing, okay? Now let's look at our frequencies. Now, there's a reason why this is highlighted or colored in salmon as well, because we need to provide those numbers from, this is where our Pascal's triangle is going to come in. So I'm going to switch tabs over to Pascal's triangle. And here it is. So like you can see, this is the whole thing, starting with when n is equal to 0, then n is equal to 1, n is 2. So we need n equals 11. So we need to scroll all the way to the right until we see an 11. And that is the column that we're going to copy our numbers from. And we need to start at the 1 and go all the way down to the last one. And you can see it goes 1, 11, 55, blah, 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 all the way down, back down to 1 again. So I'm going to have you hit Control C or Command C. So in my case, it's Command C. And you can see that I've now selected that. So I've copied it, and I go over here, and all I need to do is go at the top of in the first square that I want that to go in. So C3, right click, and I'm doing a paste special, and we're pasting only the values. So we're doing paste special, paste values. If you do not do that, you're going to get errors. Okay, so if you accidentally make an error, you can go down here in the paste options and make sure that paste values is selected. So in the lower right corner where you have your anchor, there's other paste options that you can choose from, and the paste values is there. So just make sure that that's the only thing that you've done, is pasted the values themselves. So that just copied the numbers that were in those cells. Okay, so that's column C. In column D, we're going to calculate p to the x power. So in D3, we type equals D $1, and then exponent, which is the little caret symbol above the number 6 on your keyboard, and then the cell A3. So that's equals D $1, caret A3. We're going to call that a caret, okay? Again, so with this one, you can click the anchor in the lower left corner and fill that down. Okay? In column E, now we're going to do our Q, which is 1 minus P, raised to the n minus x power. So this is going to equal E $1, caret B3. So again, equals E $1, caret, or exponent, B3. Hit enter, and again, click on the anchor in the lower right corner and drag that down. Click and drag. And now we are ready to calculate each individual probability for each of these outcomes to occur. So capital P of X is just literally going to equal the number in column C times the number in column D times the number in column E. So equals C3 times D3 times E3. And none of those is a fixed reference because we want that to be right in from that row. We want the row to update as we fill it down. Okay? So you're multiplying the frequency times P to the X times 1 minus P to the n minus X. Hit enter. And now we're going to go to the anchor in the lower right corner of that, which seemed to be, okay. There we go. Fill that down. And that last probability is so small that you may have to adjust the number of decimal places so that you actually see what the actual probability is. And, that's what we get. So just to double check that this actually is, that these probabilities are in fact big enough, because like I look at them individually and I'm like, I don't know if these add up to 1. So go down here in row 19 where we have our totals, and there's 2 totals that you need to make. One of them is here in the C column. So type in equals sum and then parentheses C3 colon C18. It won't hurt to have it go all the way down to C18 because, right now there's nothing in there, but like in the future, you might want to have stuff in there. And that number just happens to equal 2 to the 11th power, and n is equal to 11. So 2 to the 11th power is 2048. Under the cumulative probability one, we want to add up all of our probabilities. So in cell F19, type equals sum, parenthesis, and then F3 colon F18, close parenthesis.